In this module, you will learn about the multiplication operation over matrices. The multiplication of matrices is not similar to their addition or subtraction. In the addition and subtraction operations over matrices, we perform the operations element by element. In multiplication, however, we multiply the elements in a row of the first matrix by the elements in a column of the second matrix. Let's see the procedure. We have two matrices, X and Y. Let the resulting matrix of the multiplication of these matrices be Z. We will first multiply the elements in the first row of X to the corresponding elements in the first column of Y. We will write the sum of the products of the elements as shown. Then, we multiply the elements in the first row X to the elements in the second column of Y. We will write the sum of the products of the elements as shown. In similar manner, we multiply the elements in the other rows and columns. Finally, we get the matrix as shown. Let's see an example with the matrices shown. First, we will take the first row of A and the first column of B and multiply the elements one by one as shown. Similarly, we multiply all the rows of A with all the columns of B. We get the resulting matrix as shown. Here, we have to note that the multiplication operation is possible only when the number of columns of the first matrix X is equal to the number of rows of the second matrix Y. If we have two matrices, X and Y, with orders M by P and P by N, respectively, then the product of the two matrices is of the order M by N. We can generalize the discussion. Let X be a matrix of order M by P and Y be a matrix of order P by N. Let the product of these matrices be equal to matrix Z, which is of the order M by N. Each element of matrix Z is given by the expression shown. In the expression, Zij represents the element in the ith row and the jth column of matrix Z. This is obtained by multiplying the ith row of matrix X with the jth column of the matrix Y. It should be noted that the multiplication operation over two matrices does not satisfy the commutative property. This means X multiplied by Y is not equal to Y multiplied by X. However, there are some cases that we need to look at. X multiplied by Y is defined, but Y multiplied by X is not defined. Let's see an example with the matrices as shown. The matrix X is of the order 2 by 3, while the matrix Y is of the order 3 by 3. Since the number of columns in X is equal to the number of rows in Y, finding the product of X and Y is possible. On the other hand, the number of columns of Y is not equal to the number of rows of X. Therefore, product yx is not possible. Sometimes product xy and yx are both defined, but xy does not necessarily equal yx. Let's verify the case with the matrices shown. X and Y are 3 by 3 matrices. X multiplied by Y is as shown. Y multiplied by X is as shown. We can observe that though xy and yx are both defined, the matrices are not equal. If the matrices being multiplied are diagonal matrices and are of the same order, then the multiplication is commutative. Let A and B be two diagonal matrices of the order 3 by 3. Let's find the products AB and BA. We can observe that AB is equal to BA. Next, we will move to the case where the product of any two matrices is equal to a zero matrix. This does not always imply that either X is a null matrix or Y is a null matrix. Let's verify using an example. The product of these two matrices is a null matrix. We can observe that though matrices X and Y are not zero matrices, XY is a zero matrix. The multiplication property over matrices satisfies the associative law and the distributive law. According to the associative law, if we have three matrices X, Y, and Z, then X multiplied by Y multiplied by Z is equal to X multiplied by Y multiplied by Z, whenever both sides of the equality are defined. Let's see an example to verify the associative law using matrices A, B, and C. First, we will find the left-hand side. Next, we will multiply this matrix with C. we get the matrix as shown. Next, we will find the right-hand side. First, we will calculate the product of matrices B and C. Next, we will multiply A with this matrix. Both the matrices are equal. We can see that the multiplication satisfies the associative law. According to the distributive law, if x, y, and z are three matrices, then x multiplied by y plus z is equal to x multiplied by y plus x multiplied by z. Also, x plus y multiplied by z is equal to x multiplied by z plus y multiplied by z whenever both sides of the equality are defined. Now, let's verify the distributive law for the multiplication of matrices with matrices A, B, and C as shown. First, we will find the left-hand side starting with A plus B. Next, we multiply this matrix with matrix C. Next, we find the right-hand side starting with the product of A and C. Next, we will multiply B and C. Next, we will add both the matrices. Hence, the distributive law is applicable to the multiplication of matrices. Multiplicative identity exists for any square matrix. If X is a square matrix, there exists an identity matrix I of similar order such that X multiplied by I is equal to I multiplied by X is equal to matrix X.